In this video, we introduce programming moves, design and evaluation of applying embodied interaction in virtual environments to enhance computational thinking in middle school students. What is VEnvI? VEnvI stands for Virtual Environments Interaction. VEnvI is a visual programming tool that marries dance and computational thinking in pursuit of enhancing students' enthusiasm, excitement, and interest in computer science. Due to a lack of representation of minorities, especially African Americans, Hispanics, and females, in computer science and STEM fields in the United States, VEnvI was created with the intent to engage 5th and 6th grade girls with computational thinking. This research will test the hypothesis that girls creating interactive movement for their visual characters and using their bodies to think through the actuation of the characters should bootstrap their intuitive knowledge in order to learn computational concepts, utilize computational practices, and develop computational perspectives. VEnvI was inspired by Alice, Looking Glass, and Scratch. They are all programming environments that use animations to tell stories and play interactive games. Looking Glass uses linear interpolation animation, which causes the virtual characters' dance movements to look static and robotic. In an earlier study, although middle school students enjoyed seeing their characters perform, they desired more fluid movements than were available on this initial platform. VEnvI improves upon Looking Glass's user experience by utilizing motion capture animation and the Unity game engine for virtual character dance movements. We use trained choreographers to motion capture hip-hop dance moves. Using a motion capture suit, we recorded pelvis, forearms, head, and lower leg movements. The data collected from the human motion captures were used to construct a 3D virtual skeleton, which we translated and rendered to the virtual characters dancing in VEnvI. To perform our study for VEnvI, the curriculum was broken into 3 phases. Phase 1 was Learn to Dance. In this phase, students learned a dance sequence, the cha-cha slide, from an instructor as an active learning process. These dance movements will be used later for programming sequences in VEnvI. Phase 2 was Code to Dance. In this phase, students programmed dance moves they learned through embodiment into the VEnvI user interface for their virtual characters to perform. The user interface in VEnvI is divided into 3 major areas: the drag and drop area, the move selection area. VEnvI features 6 key computer science components: sequences, loops, do together, variables, conditionals, and functions. The Show Code button allows VEnvI users to see what their block sequences look like in pseudocode. The last major user interface area is the Virtual Environments window, where users can see their code being performed by a virtual character in a virtual environment. Phase 3 was Get Inside the Dance. In this phase, we created an immersive embodied experience within VEnvI to augment the visual programming model with immersive virtual reality. To facilitate the highly immersive embodied experience, we made use of the Oculus Rift head-mounted display and Microsoft Kinect V2 motion sensor. Using these technologies, the user can see their hands and feet from a first-person point of view as they interact with a dancing virtual character in a virtual environment. The intent for this interaction is for the user to dance with the pre-programmed virtual character in the virtual environment. Benefits of this immersive embodied interaction metaphor include telepresence, social presence, enjoyment, and satisfaction. In our VEnvI camp, we ran a qualitative user study to examine research questions on the impact of students' interactions with VEnvI. 16 middle school aged girls were randomly chosen to participate in this immersive embodied interaction metaphor study. Key measurements were telepresence, social presence, usability, satisfaction, and enthusiasm. For all the exciting details of our study, please see our paper as it thoroughly documents the research questions, methodology, measurements, and results. Thanks for watching our video.